Hey guys, welcome to day 14. Today's topic is the VSEPR model. Now, VSEPR stands for valence shell electron pair repulsion, and it is useful in determining the shape and bond angle of molecules. I guess where we really should start is just kind of with some examples. Okay, so the key to understanding VSEPR model is this idea of the center atom combination, and I will elaborate on that. For the center atom combination, you need to know two things. First of all, well, actually, you need to know three things. First of all, you need to know what atom is at the center, and I'm going to try to do a good job of identifying that as we go through these examples. The second part is we need to know how many neighbors that central atom has, and that's going to be a number: 1, 2, 3, maybe 4, 5, or 6. And the last thing that we need to know is how many unshared pairs or how many lone pairs that central atom has. Okay, so identify the central atom. How many neighbors does that central atom have, and how many unshared pairs or lone pairs does that central atom have? So let's just kind of dig in and do some examples here. Now, there is some stuff that needs to kind of be memorized. I did include a table of information at the very end of this document. It's probably more information than you'll ever need, but it's there if you need it. All right, so my first example is beryllium dichloride. And in this particular example, beryllium is your central atom. So if we're doing our center atom combination, we have to identify our center atom, beryllium. Now, how many neighbors does beryllium have? Well, it's got a chlorine on the left and a chlorine on the right. So beryllium has two neighbors, okay? Now, the last question we want to ask is how many lone pairs does beryllium have? Now, we realize that chlorine does have unshared pairs, but that's not our concern. Our concern is beryllium, and beryllium has 0 unshared pairs. So for beryllium, our answer is a 2 plus 0, and a 2 plus 0 leads us to believe that this atom would be linear, and that our bond angle would be 180 degrees. So these three atoms are kind of in a single file line, and if you were to make an angle ABC, that it would be 180 degrees. All right, so let's do another example. Boron trifluoride. Okay, first thing we want to do is we want to identify the central atom. In this case, it is going to be boron. Now, how many neighbors does boron have? 1, 2, 3. So boron has 3 neighbors, and according to this diagram, boron has 0 unshared pairs. So a 3 plus 0 leads us to believe that this is going to be trigonal planar, and the bond angle is going to be 120 degrees. So each one of these FBF bonds is going to be 120 degrees, okay? All right, my next example is going to be methane. And I don't have a structure for methane, but I can draw one really quick. So methane is going to have carbon in the middle, surrounded by 4 hydrogens. And so the first thing we want to identify is the central atom. The central atom is carbon. And carbon has 1, 2, 3, 4 neighbors. And carbon has 0 unshared pairs, so carbon has a 4 plus 0 center atom combination, which leads us to believe that it's going to be a tetrahedron, and that bond angle, for the most part, is going to be about 109.5. Just realize these bond angles are kind of a starting point. If we were to come in here and we're going to say, hey, let's replace one of those hydrogens with the chlorine, it would still be a 4 plus 0, but it might manipulate that 109.5 degree bond angle. But assuming all 4 of those neighbors are identical, 109.5 is a good starting point. All right, next example is ammonia. And if we're going to look at ammonia, we identify nitrogen as being the central atom. Nitrogen has 3 neighbors, and nitrogen has 1 unshared pair. So the center atom combination for ammonia is going to be a 3 plus 1. It's going to be trigonal pyramid, and bond angle is going to be 107 degrees. Kind of hard to see in this diagram, but it kind of would be a pyramid if you were to draw it. What you would notice is that those 2 unshared pairs kind of sit on top, and it kind of forms a pyramid structure kind of down below. All right, next example is water. Water has oxygen as the central atom. Oxygen has two neighbors, and oxygen has two unshared pairs. So a 2 plus 2 configuration is going to be bent, and generally speaking, about 104.5 degrees. Not exactly 104.5, but pretty darn close. And these lone pairs, what you guys are noticing is that we're adding more lone pairs compared to the previous example. This bond angle got a little bit smaller. So that's what that last bullet point tells us, that lone pairs usually require a little bit more space. So ammonia had only one unshared pairs. It had a bond angle of 107, but now we get to water that has two unshared pairs, and that bond angle shrunk by about, 2.5 degrees to about 104.5. All right, next example, phosphorus pentachloride. All right, so phosphorus is going to be in the middle. There's your phosphorus. And phosphorus has five neighbors. Phosphorus, you can't really see it, but it has 0 unshared pairs. Now, 5 plus 0 is an exception to the octet rule, and that's okay. It does happen when these D sublevels get involved in bonding sometimes. A 5 plus 0 means it's a trigonal bipyramid. So we actually have a couple of different bond angles. If you look at the bond angle between these, let's see, if you look at the bond angle between these three chlorines, this one, and this one, these bond angles are all going to be 120 degrees, okay? 120 degrees for those. But let's go ahead and look at a different bond angle. If you look at this bond angle right here, this one is going to be a 90-degree bond angle, as will this one. All right, so you have a combination of two different bonds. You have 90-degree bond angles, but you also have 120-degree bond angles. Let's see, another example. We also can have center atom combinations for molecules with more than one central atom, and I will use methanol or methyl alcohol as my example. So let's do carbon first. Carbon is one of your central atoms. Carbon has 1, 2, 3, 4 neighbors. Carbon has 0 unshared pairs. So for carbon, it's going to be a 4 plus 0. And for carbon, this end of the molecule is going to have kind of a tetrahedral shape, bond angle about 109 degrees. Now let's look at the other central atom, which is oxygen. Now we're also missing some lone pairs, so I'll kind of fill those in. So oxygen has two neighbors. Oxygen has two unshared pairs. So for oxygen, the end of the molecule, this is going to be kind of a bent structure. Bond angle is going to be a little bit closer to about 104.5. So just realize for larger molecules, you can have more than one central atom. All right, let's look at some of the examples, guys. What these examples do for you is they don't necessarily tell you the shape, they don't necessarily tell you the bond angle, but I am at least giving you the Lewis structures. So it should be pretty easy for you to identify the central atom, in this case carbon, and the neighbors and the unshared pairs. Same thing for selenium dichloride. At least you can identify the central atom, the number of neighbors, and the number of unshared pairs. Now the other thing that I want to show you is the table that I gave you at the very end. Just realize that some of this stuff is kind of beyond the scope of Chapter 8. Just realize this category that says hybridization. We're going to talk about that a little bit next chapter. But some of the ones that we did talk about today, we did talk about a 2 plus 0. We did talk about a 3 plus 0. I think we did a 4 plus 0. We did a 3 plus 1. I think we did a couple of other ones on here. Let's see, trigonal bipyramid. Yes, we did do a 5 plus 0. So this is by no means all of the ones, but it does kind of give you an idea of what your bond angles are going to be, what your shapes are going to be. We will talk about hybridization a little bit next chapter, but guys, use this as you're doing your homework. Identify the center atom. How many neighbors does it have? How many lone pairs does it have? And then if you know the center atom combination, you should be able to answer the questions on the Google form. All right, guys, I miss you. I love you. I'll talk to you.